Hello everyone, I have another recursive backtracking question for you. This one is a little bit strange, so maybe after I do the quick explanation, you may want to read the question again just to make sure that you know what's going on. The story is you're drunk, or actually you're just sleepy, and you want to operate the microwave because you want to heat up some milk for k seconds, where k is some integer. The problem is you're so sleepy that you can't move your finger properly when pressing the buttons on the microwave. So in this question, once you press a button, you can only move your finger down or to the right. I guess you can also not move your finger. And because of this, there are some numbers that you can't input. For example, if you want to run the microwave for 30 seconds, then you can't actually input 30 because if you start at 3, then you can only go down. So you can put in 33, 36, 39, or even 66, 69, and so on, but you can't type 30 because once you're in this column, you're stuck. You can't go to the left and hit the 0. Again, you can only go down or to the right, like this red arrow here. So the question in this problem is this. If I give you a number k, then what is the number closest to k that you can construct while observing the rule that, well, you can only move right and down? For example, if k is 30, as I said before, you can't make 30 because you can't hit 0 after you're hitting 3. Then what is the closest number that you can make? If you start at 3, you can't make 31. Okay, you can't make 32 either because both of them require you to go to the left. So the closest you can get is 33. But you don't have to start at 3. You can start at 2. And if you start at 2, you can actually make 29 by going right, down, down. And this actually is the closest number to 30 that you can construct. So of course, if you can get the actual number, for example, if k is 33, then you just return 33 because you can make it. You can see a few more examples down here. So for 83, the closest you can get is 80. For 132 is 133. Let's look at 83. I guess if you start at 8, the only option you have is 88, 89, or 80. I guess 80 is the closest to 83. Okay, so hopefully the question makes sense to you now. Now, if k can be anything, as in any integer, then this is actually a very hard question in my opinion. Especially as k get larger and larger because the number combination is just massive. But there is one extra condition that makes this question a lot easier, and that is the value of k that you're going to get. It is guaranteed that k will be between 1 and 200, which is actually a very small number. And this line here makes all the difference. Okay, so what I'd like you to do now is to just take a moment to think about how you would solve this problem, as in what would be your approach, because my solution might be different to what you have in mind. So you can stop the video for a bit, read the question again if you need to, and have a think about how to do it. Okay? Right, let's talk about my approach. I want to say that when I read the question for the first time, I thought, oh my goodness, this is hard. Usually when I do a question, I have an input in mind and I think about how I can generate the output for that input. And the input I had in mind was 30 actually, which is the example I used earlier. I was thinking, what do I do if I have to find a number closest to 30? By the way, as I explained before, the answer is 29. So I was thinking, if I get 30 as an input, I can't start with 3 because that will give me the wrong answer. But if I start at 2, what if the input was something like 35? As in, it'll also start with 3, right? But now I'm starting at 2, so the best I can get is actually 29, whereas the best answer would actually be 36. That would be the closest number to 35. So I was thinking in my head, like, do I have to look at everything starting with 2? I have to look at everything starting with 3? Do I have to look at everything starting with 4 even? Does it mean I have to generate every single possibility? And this is when someone told me that k can only be between 1 and 200. Someone told me to read the question properly, which I did. So it is actually not that bad because we can generate all the possible numbers. Again, 200 is tiny for a computer. So here's the approach that we're going to take. We're going to generate all the possible numbers between 1 and 200. We're going to put these numbers inside an array, and then we're going to sort the array. So when we have to find the number closest to k, that's easy. You just traverse through the array once. How do we generate all the possibilities? Well, obviously we're going to use recursive backtracking. So now let's think about the structure and how we can break down the problem into smaller subproblems. What is my starting point? Well, if I'm going to generate every possible combination, then it would make sense to start at 1, that is the top left, right? Because then you'll have the option to press every button. And we'll do something similar to what we've done in previous videos. So right now, imagine that your finger is here. You can either press 1 or not press it. So it seems like you have two options. Pick 1, don't pick 1. But actually you have more than just two options, as in, okay, after you pick 1 or not pick 1, you have to decide where to move, or if you want to stay at 1. So actually there's a few more options here, and I'll try my best to illustrate it. I can pick 1 and then stay at 1, so that's one option. So I'm just gonna put 1 in these notes here. So this is telling you where your finger is. And if I pick this path, this means I stay at 1. Because I can also pick 1 and then move to 2. Or I can pick 1 and then move to 4. So these are the three possibilities if I decide to pick 1. What if I decide not to pick 1? Well, you can go to 2 or you can go to 4. Would you stay at 1 though? Well, no, because if you do, then, well, you're going to be there forever, as in, you're at 1. Okay, I'm not going to take 1, but I'm not going to move my finger, so I'm just going to say 1, and I'm not going to move my finger again. So what are you going to do? You're just going to put your finger on 1 all the time? Okay, so we got to make a rule that if you don't take the number, so if you don't take 1, then move your finger somewhere else, because otherwise you're going to be stuck there forever. So what if you take 1 though and you stay at 1? Can you do this indefinitely? Well, no, because we want to generate numbers between 1 and 200 only. So if you pick 1 3 times, you're going to get 1111. That's too big. So we can tell our program to stop. When you exceed 200, when the number you're making exceeds 200, just stop. So I won't pick 1 anymore, and this 3 will get cut off here. It will not go to the bottom infinitely. What if you're at 2? Is it going to be the same rule? I'm going to separate the node because it'll get too crowded otherwise. The rule is kind of the same because you can either stay, you can go to 3, or you can go to 5, and this is the options if you actually pick 2. You have the same number of options. If you don't pick 2, you can go to 3 or you can go to 5. So same structure, but is it the same for all the numbers in the keypad? Well, let's say you're at 3 now. How many options do you have? If you pick 3, then you can stay at 3, or you can go to 6. If you don't pick 3, then you have to go to 6. So it actually got simpler. In this scenario, you have less options. And this is what you have to code basically. There are 10 keys, and depending on which key you're at, depending on which number you're on, you have to control the flow of your recursion according to the rule. Well, these are some of the rules. You also have to think about what moves you can make when you're at 4, 5, 6, all the way up to 0. This is the approach that we're going to take. So make sure you understand how this works before we start writing the code. In fact, maybe you already know how to code this, so you can get started and you can compare your code to mine later. Okay, let's start writing the code. I'm gonna leave these pictures here as a reference so we know what we need to do. And one more thing, in the question, the first integer input is the number of cases that you're going to get. So how many cases are they going to give you? Now, as you can see in my code, I start reading the input here. but I'm actually going to do some work before I read in any input. Why? Because it doesn't matter if they give you 100 numbers or 200 numbers. You only need to generate all the possible numbers once, and then you can use it again and again for each new value of k. It would be stupid if we generate all the possible numbers every time we get a new value for k, because we'll just be doing the same thing again and again and again. The set of possible numbers will never change. It's fixed. So what we should do is we will generate all the possible values before we take in any input, and from then on, every time we get a new value of k, all we have to do is just look if k exists in the array of numbers that we generated, or if it doesn't, we just return the closest number. And I'm going to put the numbers that I can generate inside this set values. Well, for now, I'm going to put it inside a set so I don't get duplicates. And once that's done, I'm probably going to put it inside an array list and then sort it. So we're going to start by writing a function that will recursively find all the combination. What do I want to call the function? Let's call it generate. I don't have to return anything because whenever I get a new value, I'll just chuck it inside the hash set. What kind of input do I need? I need to know which number I'm at, as in which keypad. It's going to call it digit. And I also need to know what is the number we've constructed so far. So I guess I'll call it number. Do I want to make it a number or do I want to make it a string? Because if I have a string, I can just keep on concatenating the new digit. I guess I can do multiply by 10 and add the digit. All right, I'll just keep it as an integer. Let's just make it easier. Okay, so when do we stop? We will stop if at any time the number that we're making gets above 200. So that's when we say stop. Don't bother going any further. Where's the picture? Yeah, remember, if we keep on picking 1, then eventually we'll stop because we exceed 200. This if statement will do it. And let's construct what we should do if the digit is equal to 1. Okay, let's do these ones first. So if I'm at 1 and I choose not to take 1, that means I have to recurse. And the next time around, I can be either at 2 or I can be at 4. And if I don't take the number, that means I'm just going to pass it on. Sorry, maybe I should call this sum or value. Yeah, if hub number is okay. This is the number that we're generating. I hope that variable name is okay. It's just a bit confusing when I say number all the time as well. Okay, if we go to 2, we can also go to 4. And those are the two options if we don't pick the number 1. If we do pick the number 1, then how do we incorporate 1 into the number that we have so far? Okay, I'm gonna use digit. If we pick the digit 1, how do we incorporate the digit 1 into the number that we have so far? Well, number is gonna be number multiplied by 10, shift it to the left, and then we will add digit to it. So now, if the number that we just created is less than 200, well, less than or equal to 200, we can add it to the set values. So values at number. If it is greater than 200, doesn't really matter because we're going to recurse and it will be caught by this if statement here. So I'm just going to call generate. We can stay at 1. The number will be different now because we just incorporated the last digit that we see. And we can do the same thing for 2 and for 4. So that's it. That's the recursion rule if you're at the digit 1. If you're at digit 2, should be the same. Okay. Because we have the same number of options. You saw that earlier. I don't have the picture here, but 2 can go to 3 or 5. This part should be the same. This part should be the same. And you can go to 2, 3, 5. If you're at 3, you can not take 3. If you don't take 3, you have to go to 6. Okay, so generate 6 number. And if you do take 3, so I'm gonna copy this. You can go to 3 again, or we can go to 6. This is really boring stuff, but I really can't think of any pattern that I can use to shorten the code. And also, this is pretty easy to just copy and paste. You just have to be careful when you're doing it, make sure you don't make any typos. I guess it is not ideal because it's going to be a long code. I'm gonna stop the video and do it. I'll do 4, 5, 6, 7 and so on. Actually, let's do 9 and 0 because they're slightly different. Because with 9, you can't go anywhere, right? So if digit is equal to 9, then all we can do is, well, if you don't take it, then that's it. You're not going to be doing anything. So no more recursion if you don't take the number. So we're going to take the number, and I should just copy this. Oh, whoops, I just realized I forgot this line. And after we take the number, we can repeat 9. Similarly for 0, it will be the same, right? So if the digit is 0, trying to think. I think I recall doing something tricky here. Well, not tricky, but there's something else I have to worry about here. If I get the 0, oh, okay. If you get a 0, you don't want to make 0, 0, 0, 0, 0, and so on. So I'm gonna say if number is not equal to 0, we can generate 0 and a number. So the thing is, if you got a 0 and you keep on going to 0, you're gonna get stuck because number will always be 0. You'll never go up because 0 times 0 plus 0 is going to be 0. You're going to be stuck in an infinite recursion. So if the number is actually not 0, maybe something like 5, 0 or 6, 0, then you can try to add another 0. Well, I guess you won't because that will be more than 200. But if you get 10 as a number, then you can add 0 to it. I think that is it. So I'm gonna stop the video. I'm gonna fill up the rest, and you can do this on your own as a practice. And when I come back, we'll try to submit it. Actually, no, we haven't done any. We haven't finished the code. We've done half. We've done half of it because we generate all the numbers, and now we just have to do the bit where we find if k is in the set of generated numbers. Okay, I added all the cases, and I guess I noticed that 1, 2, 4, 5 have the same structure. So if you want to, you can kind of combine these two, because you can either go to the right, which will add 1, or you go down, which will add 3 as the next number. So something like digit plus 1, digit plus 2, oh sorry, 3, and you can do that for digit equal to 1 or digit equal to 2 and so on. You can do something like that to shorten the code, but I already did a lot of copy and pasting, so we're going to stick with this. Now we can check if we did generate all the possible values. So let's just add this. Oh, we have to start the chain, and we're going to start by starting at 1. So generate 1, and the number we have at the start is 0. Save it, and I'm going to run it. And you can see here I got a whole bunch of numbers. They're not sorted, so we have to sort that. Not a big deal. We're gonna make a new array list. R, and this is just going to be from the set, so from values. We're going to convert the set into an array list. I can just use bar, I guess. And I'm going to sort the array list. So collections dot sort. Do we want ascending order? Yes, we do want ascending order. Okay, let's print that out again. Oh, whoops. Sort. Okay, so these are all the possible values that we can generate from 1 up to 200. And now we're just going to find if k is in there. Because the first thing we can do is if R contains k, then we just system output k. Now, if k is not in the array, then we have to find the closest number to k. And how do we do that? Well, let's say that the array contains, I don't know, 21, 24, 25, 26, I don't know, like just some example. And k is equal to 23. So what we have to find is, well, we know for sure that 23 is not going to be in there. So we got to find the index, well, two pairs, one pair of index, such that the first one is smaller than 23 and the next one is bigger than 23. So that's got to happen. You may get to the end of it, but we know that this is going to happen. So do an else here. So we need a loop going from 0 up to R dot. I need to go one less basically, because the last j should be the second last element, not the last element. Because why? I want to look at two elements at a time. So here, if R get j is less than k and k is less than R get j plus 1, then we know that k is going to be, well, k is closest to one of these numbers. So what do I do? I have to find which one is closer. Let's just do a minus. So number, k minus R get j. If it's less than R get j plus 1 minus k, because we know j is going to be smaller and j plus 1 is going to be bigger. Then we're going to output R dot get j. If that's not the case, we're going to output R dot get j plus 1. I think that is it. So we don't need this. Let's give it a go. See if we get the same output. So what's the number that we're going to try? 180, 83, and 132. Okay. 3 cases. 180, I get 180. Good. 83, I get 80. And 132, I get 133. Okay, I'm going to try to submit this, and I'll let you know if there's a problem. Okay, it got accepted, but there are only 2 test cases, so I hope the code is correct, but you never know, maybe I just got lucky. But the approach seems pretty solid. So what I did here, again, let's do a brief recap. I generated all the possible values between 1 and 200 using this recursive function here. This is again similar to the ones that we've done before in the previous videos. When we do recursive backtracking, we always try to generate a number. It just happens to be that the last few videos always do the same thing, as in generate a number. So generate all the numbers, lots of funny rules, well, not funny, just boring rules, and then we process the inputs one by one. We get a different number every time. We get the different values of k, and we just check if k is in the array or not, and if it's not, let's return the closest number. That's it. At the end of the day, I think it's a pretty simple code still, but it's a nice practice for recursive backtracking. So that is good morning. I think it's a nice question, and hopefully this gives you more practice on how to do recursive backtracking. Okay, so that's it from me. Thank you for watching.